Iron is an allotropic metal, which means it exists in more than one type of lattice structure. In normal room temperature, lattice arrangement of iron is BCC. Whereas at 908 degrees Celsius, it changes to FCC gamma, and then at 1403 degrees Celsius, back to BCC again, and vice versa. Alpha iron is stable at lower temperatures, and gamma iron is stable at higher temperatures. The x-axis represents the percentage composition of carbon in steel, and the y-axis represents the temperature in Celsius. Pure iron melts at 1539 degrees Celsius. Cementite melts at 6.67%, and carbon melts at 1550 degrees Celsius. The steel begins to solidify when it reaches a temperature corresponding to the line ACD. Steels, containing less than 4.3% carbon, start precipitating austenite crystals, and at temperatures above 4.3% precipitate cementite. Austenite is the solid solution of carbon in gamma iron. Steel solidifies at temperatures along the line AECF. Steels containing 0.8% carbon and below solidify completely at temperatures corresponding to the AE line and consists only of austenite. Cast iron, containing 2 to 4.3% carbon, solidifies at 1130 degrees Celsius. Austenite crystals precipitate simultaneously with cementite to form ledeborite. These cast irons will consist of primary austenite and ledeborite crystals. Cast iron, containing 4.3 to 6.67% carbon, solidifies at 1130 degrees Celsius and consists of primary cementite crystals and ledeborite. After this primary crystallization, all steels consist of austenite and all cast irons consist of cementite and ledeborite. The secondary crystallization occurs in the solid state. The upper critical temperature line, GS, indicates the beginning of austenite decomposition and the precipitation of ferrite. The line SE indicates the temperatures at which austenite decomposes to form secondary cementite. Point S, corresponding to 0.8%, shows the minimum temperature at which the austenite can exist in equilibrium condition. At point S, austenite decomposes to precipitate cementite and ferrite at the same time. This results in the formation of pearlite. At normal temperature, hypoeutectoid steel will consist of ferrite and pearlite. Hypereutectoid steel will have a structure consisting of pearlite and excess cementite. On complete cooling, hypoeutectic cast iron will have pearlite, ledeborite, and secondary cementite. Hypereutectic cast iron will consist of ledeborite and primary cementite.